There we go. We're back.
Right. So if you've got your table of Laplace transforms, you should see that a ramp, can't remember what it looked like, is it just T, isn't it? And then that's 2 over S squared.
Quick question, does the title say ramp into C?
Ramp into C, yeah.
Okay, cool, thank you.
Ramp into capacitor.
Yeah.
All right?
Yeah,
so
yeah, we're good.
Having written those two, we can write an expression for I, which is I is equal to 2 over S squared.
Okay, yeah.
Over 1 over 8S. Yeah. And then we have to do turn the bottom fraction upside down and multiply. So that's I is equal to 2 over S squared times 8S over 1. Yeah.
Yeah.
Write a little neater, Michael, please. 2 over S squared. Yeah. Okay.
It's 2 over S squared minus 1 at 8. Is it minus 8S over 1? Yeah.
No, it's times.
Oh, okay.
Yeah.
Yeah.
So that is equal to 2 times 8S is 16S over S squared. Yeah.
Oh.
How can we? And then we can simplify that, can't we?
Over, what's that? Over 5S. 5 squared.
No,
sorry.
That's S squared.
S squared. Damn, 5 S's, Mike. Come on now.
Oh, I'm trying. All right.
I'm confused. Is that a 5 or an S? I'm confused.
That's an S.
That's an S, Peter.
Okay. Right, I'm with you.
All right.
Yeah.
So that is equal to the S on the top can cancel out and one of the S on the bottom. So you end up with 16 over S.
Super duper.
Yeah. Does 16 over S look like anything in your table?
Oh shit. 1 moment.
Looks like.
Is that
A over S?
Step or DC function?
Looks like I over S, and that transfers back to I at T is equal to 16 amps. Yeah?
Yes, yeah.
Constant current. So in answer to your question, Kieran,
yeah,
neither of them are right.
Oh.
The correct graph is...
Would it be a straight line going from the bottom left corner?
It's not. How do you draw a graph of a constant, Peter?
Diagonally.
That's what I said.
16. If here's 16 amps, and the current is constant 16 amps, straight line across there.
I kind of feel like this was a trick question. You expected us to get this wrong.
I did. In the notes from previous years, I had I didn't have exactly the same two guesses. I had the red one, right? And I also had a straight line like this, but sloped down that way.
Oh, I see. I kind of feel like I was closer out of the two of us, so I'll take the win.
No, I'd say I was.
Neither of them are very close. But anyway,
thanks, Mike.
Serves a purpose. All right. Okay. So, what I want you to do, just for safety's sake, is have a go at this one. capacitor, 300 microfarads. Ramp input of 40 volts per second.
What was the value of the capacitor on the other circuit? I just realised you didn't write that down.
8
That was
farads.
8S.
Thank you.
Come on.
8 farads. So in S space, it's 8. 1 over 8S.
What did you say that 40 volts per second, was it?
Yeah, I just rubbed it out to try and write it a bit neater,
Oh.
Kieran. Do that. That's not easy writing on glass. As you've got
No, I bet it's not.
no resistance.
Oh yeah, that's true.
$300 times.
Is 200 nanofarads 0.02?
That's
That's
300
300p.
microfarads.
Oh, sorry, I've written 2. My apologies.
That's 10 to the minus.
6.
Oh hell.
That look like microfarads now, Peter?
There's 0.0003.
Yes.
0.003. Yes. So I is equal to.
Right. So we got that
Oh, this
expression
bit's
for
up there
the.
as well.
We could do a bit more to this impedance. If what we're going to do is multiply by 2 plus S over 2 plus S. Effectively, we're multiplying by 1. Yeah?
Yep.
And that is the whole thing, including the 10. Yeah? So we got 10, 2 plus S over 2 plus S times, so plus, no, that's just the 10 we're multiplying by. So we're just multiplying this bit by that. Yeah.
Oh,
So we
okay.
have 20S. Can you see what we've achieved by doing that?
Yeah.
We have a common denominator.
Cool.
That's what we got. 2 plus S, 2 plus S.
So,
Agreed?
I see.
Right.
Yeah.
Yeah.
Oh, that equals.
All right.
Yeah.
Then we can multiply brackets. So that becomes 10 times 2 is 20 plus 10S. Yeah. Plus 20S over 2 plus s. And then we can bring together these two into a I'm not doing very well here today at all. Sorry, boys.
No, you're all right, mate.
I can see what's happened. Flicked back to the other page. Yeah. So we've got on the top here now 20 plus 30s over 2 plus s. Now we're getting somewhere. Yeah.
Well, just quick, that wouldn't be. Oh no, it would be 30s squared, wouldn't it? Because you're plus and not times them.
No, you just added them up. So we got 2 s terms. We can add them together to simplify. All right.
Mhm.
Now we can put that into expression phi. So I'm just going to take that. And we can say phi s is equal to our voltage 10 over s divided by this expression here for z. 20 plus 30s over 2 plus s. Yep.
Yeah.
And then we can tidy the fractions, so we can say that's equal to 10 over s times 2 plus s, turn this one upside down, over 20 plus 30s. Yep.
Mm-hmm.
Which you can then say is equal to 10 times 2 plus s over s 20 plus 30s. What are we into now? What have we done in previous weeks with an expression like that?
We.
Do we want to get s on its own or something like that?
No, we've had a
Does this have to do with the numerator?
We've had a constant on top, but we've had a term like this below where we've got s times a bracketed term.
Oh, you have to find out what s equals. Is that right?
We have to get it to look like something in a table as the ultimate.
You equate the numerators?
Yeah, you're almost there. We got to write it as partial fractions, so we can say that it equals this bit here. This expression can be written as 10 2 plus s over s 20 plus 30s is equal to I over s plus b over 20 plus 30s. Yeah. And then now we need to do partial fraction on that expression. Yeah. Using a lot of pages here, aren't I?
Yeah.
So can you remember what we need to do?
We need to let. Do you have to let
First
S
of all,
equal 0?
First of all, we've
Oh
got to
yeah,
make
that's it.
we've got to get the common denominator back, haven't we?
Oh right, yeah.
So we have to multiply A by 20 plus 30s.
Yeah. And plus BS. And then would that be all over S
Plus
20
BS.
plus 30s?
Yeah, because then we can have the common denominator back. Remember that, Peter?
Yeah.
Yeah. Now we can equate the numerators. Because we've got the common denominator, so 10 times 2 plus s must equal that on that fraction, this fraction must equal this bit on here. So then we can say let s equal 0. So
I haven't used this much paper in ages.
10 times 2 plus 0 equals I times 20 plus 0. Yeah.
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 So this is us 20 this side is equal to 20a. I equals 1.
Hang on. What? Ah, yeah. Okay.
Yep.
Yeah. So,
And then we need to let 20 plus 30s equals 0, because if we do that, yep, 30s is equal to minus 20. Yeah. S is equal to minus 20 over 30. Equals minus 2 over 3. Yeah. So then we can say, therefore, 10 times 2 minus 2/3 is equal to B times 2/3 minus 2/3.
I've confused myself.
Just B times minus 2 over 3.
Yeah.
Okay, thank you.
So, so what was that? 10 bracket 2 minus 2/3.
Yeah.
And then equals B times minus 2.
That comes out as, you should get B is equal to minus 20. Because you're going to divide.
You're going to divide that, yeah.
So in your calculator, if you do.
Oh yeah, because that'd be
10.
If you'd eliminate the 2/3, wouldn't you?
2/3. I find it easier just to put it all in the calculator. So 10, and then divide that by minus 2, over 3. That's what's in my calculator. Can you see it?
No, for some
No.
reason, when you talk, Mike, I've only got a little animation figure. I can't see you.
Oh,
Yeah, that's
okay.
what I've got.
Anyway, when you press equals, you get minus 20.
2, 3.
Yeah.
I've got 20 on mine. What have I done wrong here? The 20
Well,
on
you
mine
missed
is
one of-
20.
You should be doing 10 times
Yeah.
brackets 2 minus 2/3.
Yeah.
Yeah. Close the brackets
Yeah.
and then divide the whole lot by minus 2 over 3.
Oh, yeah, because you're not. Yeah, sorry. I put 2 over 3.
You probably divided by just 2 over 3, yeah?
Yeah, because I changed minus 2 over 3 when I moved over, which I shouldn't. Yeah, minus 20.
So we've got A is equal to 1, yeah, and B is equal to minus 20. So one more new page for me. I want this bit over here.
It's a bit of a long, old-winded question, this one, isn't it?
Is equal to. It is, yeah.
Yeah,
So
no,
A
put
was
that
1,
back
wasn't
into-
it?
Yep.
Yeah.
So it's 1 over S minus 20 over 20 plus 30S. Yeah,
So B was 20, not minus 20. Sorry.
it's minus 20. So
Oh,
let's
it's minus
change
20.
this sign.
Oh,
Let's change
yeah,
this
I'm with it.
sign here to a negative.
Yeah, I'm with you. I'm with it.
All right.
Yes.
So now we can divide by 30 to get S on its own. Just this part, the right-hand part of the expression. So we got 1 over S minus 20 over 30 is 2/3. Yeah. Divided by 2/3 plus S. Yep.
Yeah.
Yeah.
Change colors. This bit looks like A over S.
Yeah.
Yeah. And this bit looks like I over S plus B. Yeah.
Yeah.
So converting that back, we get I at T is equal to 1, yeah, minus 2/3 E to the minus 2/3 T.
Yeah.
Yeah.
Uh-huh.
Yeah.
What do you think that graph would look like?
Swooping down from top left to bottom right.
Top
God,
left to bottom right.
did you just guess that, Pete?
I just went for the same
Like that?
graph. Yeah, that's what I reckon.
If we go back to
Mm.
the
think you might
circuit
be
in the
wrong,
first
Pete.
place, if we go back to the circuit in the first place, right? What's gonna be the situation